Hi guys, the topic of discussion in this video is fuzzy logic. Now if you guys remember predicate logic and propositional logic, what we were trying to do in both those cases was try to find out truth values of our propositions. Now there is a small difference between those propositions and our fuzzy statements. Now those propositions they always are certain to some extent. That is, we can tell whether they are completely true or whether they are completely false. But fuzzy statements are different. The reason being, you cannot say whether a statement is completely true or completely false. You've already seen why this is happening. Now, in order to challenge them or in order to try and understand them, we're going to use fuzzy logic. And as I've already mentioned, we do not have just true or false here. We have a degree of truth of a statement that can range between 0 and 1. So there are infinite possibilities here. So as I already told you, the main goal here is to understand uncertainties that we have in propositions. So that is the reason. I'm not sure if this is legible. So this is the main reason why we are trying to study fuzzy logic. Now, just like it was the case in predicate logic or propositional logic, we mainly focus on natural language here. So whatever degree of truths that you are learning, you always learn them with respect to some sort of English sentences. Now fuzzy logic consists of four main components, and they are these: fuzzy predicates, fuzzy truth values, fuzzy quantifiers, and fuzzy modifiers. So what are fuzzy predicates in terms of regular English words? So you could consider something like old, expensive, young. So these could also be called as let's say your predicates in the case of predicate logic. But there is a clear difference between that definition and this definition, and that will be much more clearer when I get to these topics in much more detail. Now truth values in the case of propositional or predicate logic, they were just T or F. But as I already told you, we have infinite possibilities here. So if you were to put them into English words, you will get fairly true, true, very true, fairly false, and then you can have infinite such English words. Fuzzy quantifiers. Now in predicate logic, that's the first place where we already saw quantifiers. And over there we just have had a couple of them. We had for all and we had there exists. Over here we have more quantifiers. The reason being, you can have words like many, few, almost all. If you look at all of these, they're ambiguous. That is, with for all and there exists, you can clearly say that, okay, fine, you're talking about an entire entity or you're talking about some entity that exists. But when you say many, that is a very ambiguous definition. Some might consider 3 out of 4 as many. Other person might consider 2 out of 4 as many. So everyone has their own definitions. So that is the reason these quantifiers are ambiguous. This fourth part right here, fuzzy modifiers, they're quite different. These are not present in your previous logics. So examples for them are likely almost impossible. Usually these modifiers are used in conjunction with your fuzzy quantifiers and your fuzzy truth values. So these are also called as hedges. We'll learn about them in detail as well. So let us first try understanding what fuzzy predicates are in much more detail. So here is a definition of fuzzy predicate. You can go through it. I'll just read it out anyway. So if F is a fuzzy set and we have a statement X is F, then F is called fuzzy predicate. We pretty much have the same definition for a regular predicate in the case of predicate logic. So let us try understanding this with the help of a small example. So we have a small sentence here, John is young. This can pass by as a regular predicate statement as well, but since we are dealing with fuzzy statements, let us consider this as a fuzzy statement. So this we can rewrite it as something like this, young of John, in predicate form. So we here I say that young here is the predicate. Now why is young a predicate? The reason is young qualifies what John is all about. So that is the reason we term this as our predicate. But this predicate is not equivalent to, like, let's say boy of John. Like if I say John is a boy and then I would say boy of John. So how is this boy different from this young? Now I cannot say that John is, I have 0.5% 0.5 degree of confidence that John is a boy. If I know that John is a boy, I know he is a boy. If I do not know that John is a boy, then I know that he is not a boy. That's it. It's either 1 or 0. But in the case of fuzzy statements, when I say that John is young, everyone might have different interpretations. So for that very reason, we represent this fuzzy predicate as a fuzzy set like this. So if John is, say, 5-year-old, then he is definitely young. Everyone might consider him as young. If he's 10, he's still young. 25, most people might consider him to be young. 30, still young. 60, not really young. 70, very few people might call him young. 80, definitely no one calls him young. So this is the way a fuzzy predicate is different from your regular predicates. Now let us go to the next topic, fuzzy truth values. So how are these fuzzy truth values even formed? So we already saw that they are not just about true or false anymore. We have fairly true, we have very true, we have fairly false, so on and so forth. So these fuzzy truth values, they are formed by using these fuzzy modifiers or hedges. So they both mean the same thing. So these are added to your true or false, and then that's how you get your fuzzy truth values. And just like your fuzzy predicates, your fuzzy truth values are also fuzzy sets. So where are these used? We'll try understanding this with an example, but before that, let us try understanding where these fuzzy truth values are used. So we have a couple of applications. Only one of them is in your syllabus, and that is on your screen. Interpretation of fuzzy statements. So that is what we are looking at. So consider we have a statement that says John is young, and then we have 0.8 confidence in it. Now that might sound odd to a person. We definitely want to say to another person that John is young has a confidence of 0.8. Instead, use something like fuzzy truth values. How? Let us try mapping out all the membership functions of each of these fuzzy set truth values. Here I have represented just 3 truth values. This is fairly false, this is true, and this is very true. Now with these membership functions, I'll try map out my 0.8 to any of these membership function values. Now if I try mapping that, I get very true with a confidence of 0.9. Now what 0.9 says is that, okay, you could map this 0.8 to very true with a confidence of 0.9. It might sound a bit confusing. I want you guys to think about it a minute to try understanding what I'm saying. So what 0.9 actually says is, I could represent or map the 0.8 to very true. Now if this 0.8 was, let's say, mapped to some point like this. Now this, if I map onto the graph, I would get a value like, let's say, 0.3. Now 0.3 is not a big number, so I cannot say with much confidence that I could directly map 0.8 with very true. But since I have 0.9 degree of confidence in it, I'll definitely map it with very true. So instead of saying John is young has degree of truth 0.8, I can instead say John is young, the statement is very true. So that pretty much sums it up. The other use for this is in a qualified fuzzy statement. This is out of scope of our syllabus, but if you guys are interested, this is present in 10.8 in your textbook. So you guys can have a look at it. Now let us jump into the next topic, the fuzzy quantifiers. So as I already told you, we can have multiple fuzzy quantifiers formed with the help of our modifiers. And these quantifiers, they can be of two types. So one type of quantifiers, they can be quantified on real numbers. So what do I mean by that? So you can say something like as much as 5. So I can say there are as much as 5 mangoes in a basket. So that could qualify as a fuzzy statement which has a fuzzy quantifier on real numbers. The other type is where you have everything defined on an interval of 0 to 1. So what do I mean by that? So you could use some quantifiers like about half or almost all. So maybe I could use an example like almost all students in this classroom are excellent. Now there are like multiple fuzzy quantifiers, fuzzy predicates in this, but anyway, if you were to like consider the entire class as 1, entire class strength as 1, and then half of it would be 0.5. You do not have to like look at 65 or 66. So you could even define it on an interval of 0 to 1, or else you could define it with a real number like this. Now you could like represent different type of fuzzy quantified propositions. We're going to look at 3 types. There are many more. You can like Google them up, you can find many more. But in this syllabus, we're only going to cover 3 of them. The first kind of quantifier has this shape. So if you have a sentence like this, there are qi belongs to I such that x of I is f. I know that doesn't make any sense. Let us try understanding that with the help of an example. So this would be a proper example to it. There are about 15 employees, efficient employees. So that is what we are looking at. So here about is my quantifier. About 15 is my quantifier, sorry. So about 15 is my quantifier and efficient is my predicate. So this is the form that we are talking about. So there is a quantifier that quantifies a predicate. So what do we understand by this? So there are some small definitions associated with it, or let's say properties associated with it. So there is one small thing here. The truth value of fuzzy proposition like this is defined as Q of mod E. So this mod E is nothing but cardinality of fuzzy set E. So definitely whenever we look at any fuzzy proposition, we definitely want to find out the truth value in it. So that is the reason these people have come up with something like this. I do not know how this definition has come about, but this is a formula that you guys might need to like remember whenever you see a form like this.